What comes next in the climate change and climate impacts on the oceans now here again? So ocean water, I think you already know the pH scale, which is the negative log of the H plus ion, basically measures how acidic a fluid is, right? So you probably are aware, or your mom or dad or someone has told you that this Coca-Cola is very acidic and it can bore a hole into your stomach if you drink too much of it, or you can take Coke and put some metal in it and see what happens to it over time, and so on and so forth. And milk is acidic, and so on and so forth. So pure water is considered, neutral, which has a pH scale of 7. If pH is larger than that, then we call it a basic solution. And ocean has a pH of 8.1 to 8.2. Some places it's a bit higher, but over millions and millions of years it has remained at this pH value. What happens if you keep increasing CO2 in the atmosphere like we are doing now, knowing that CO2 can easily dissolve into water, and the water and the air are constantly talking to each other, winds are ripping up waves and air bubbles go inside and come out. So all these things create exchange of gases like CO2 at the surface, and there are regions where the water sinks, like we said just now around Greenland, and also happens in the southern ocean of Antarctica, water sinking, that is. Heavy water forming at the surface and sinking. When water sinks also, it takes whatever oxygen and CO2 and other greenhouse gases and so on with it to the bottom of the ocean. And as you can imagine, we looked at the Gulf Stream, but we didn't say, oops, what did I do to the Gulf Stream? Oh, I just showed it online. Never mind. So that water, once it sinks, it takes it hundreds or thousands of years to come back to the surface again. So if CO2 sinks to the bottom of the ocean, it can stay there for hundreds of years. So here, acid oceans, what do we mean? 70% of the earth is covered with water. Scientists don't yet understand half of it. So they have tipped about 4,000 robots overboard from research ships. Sometimes you also drop them from a chopper or a little plane, scattered throughout the world's oceans. These robots bob up and down, and they work hard to collect the details about the oceans, like the temperature that is changing with depth, and the salinity, and the oxygen, and CO2 as well. Every robot is 2 meters long and looks like a gas cylinder with an antenna on its head here. All by themselves they dive to the depth of 1 kilometer or sometimes 2 kilometers, depending on how they are ordered to do. There is a little software that tells them what to do. For around 9 days they float along on the current as they go. They measure the temperature and the salt content of the water. They then descend to a depth of 2 kilometers. They continue measuring and return to the surface. Using their antenna, they pass on the measurements to a satellite. It's in the middle of the ocean and collecting data. Very nice, but what is it collecting? We have to get it. So it comes to the surface, uses the antenna, sends the data to a satellite, just like you're getting your cell phone signal or your Wi-Fi with some help from the satellites and networks and so on and so forth, right? So they continue measuring and they return to the surface using their antenna. They pass on their measurements to satellites, and then they dive back down again till the battery runs out, which typically takes 3 to 4 years. Thanks to these robots, we know that the oceans have absorbed a lot of CO2 and a lot of heat in the recent years. So much, in fact, that for about 15 years it looked as if Earth was hardly warming up at all, even though CO2 was increasing, as we saw. But now it turns out that the oceans were taking up all the heat and hiding it away. In recent years, this has been happening more slowly, it seems as if the oceans are almost full of CO2 and heat. Right? If you take a glass of water and you start dissolving salt or sugar into it, at some point it will not dissolve anymore because it is saturated. Okay, CO2 disappears in the water in various ways. Algae and the plankton use it to make oxygen. Photosynthesis happens, but CO2 also partially dissolves in water. This creates carbonic acid, which you know as the fizz in fizzy drinks. This carbonic acid is making the oceans more and more acidic, and acid burns. That's not good. You can't taste it, but it's bad news for the corals and the algae and the phytoplankton, which depend on the ocean pH being where it was for millions of years. They grow less, and so they can absorb less and less CO2. This can be seen even in the latest measurements from the robots. So here we are looking at a coral that has become white, which means it's not colorful, which means the algae that live on it and do photosynthesis and take away the CO2 have died because of the warmth and the acidification. There is our rubber ducky again, and you know the acidification and the dissolution of CO2 into liquids with your Coca-Cola, and there is a little seahorse looking scared at this Coca-Cola. What is it showing? It's showing that when the Coca-Cola is cold, it has lots of CO2 bubbles in it. But if it's not warm, it's going to let out all the CO2 bubbles. This is why you keep it sealed. It's got high pressure and cold temperatures so that it can hold on to the CO2. If you open the cap, it will start escaping because the atmosphere has less CO2 than in the Coke, so it will come out. If you let it warm, then also it will come out because cold water holds more CO2 than warm water. So here is a nice brain coral, and there are other kinds of animals that need calcium carbonate, which gets dissolved if you make the water acidic. Like when you have an upset stomach, maybe your mom will give you a little Pepto-Bismol or what is called an antacid. It reduces the acid in your stomach. Same thing happens in the oceans as well. Okay, the warming of the water is also a factor because warmer water is worse in holding on to CO2. You can test this out for yourself with 2 cans of soda. Put 1 can in the refrigerator and 1 in a warm place. When the first can is nice and cold, open both the cans. Watch out, if the warm can is very warm, the soda will come shooting out or frothing out. The warm soda loses its fizz really quickly, while the cold one will fizz away quite happily for some time. Taste it. Cold soda will be much fizzier. The fizz is coming from CO2 in the drink. Cold liquid retains CO2 much better than the warm liquid. This is true for fizzy drinks and for the water of the oceans as well. In warm oceans, the CO2 disappears into the atmosphere much more easily. So the oceans slow down the warming of the earth by absorbing CO2 as well as the heat. But in an ocean that is warmer and more acidic, less and less of CO2 goes in. There comes a point when the ocean will not be able to take any more CO2. So more CO2 remains in the air if it doesn't go into the ocean, which means the temperature in the air begins to rise more quickly. Global warming will accelerate. Okay, so we'll come back and talk about stormy weather. Each topic is very important, and you should listen and make sure you understand and ask questions and read up more and listen to more videos, watch more videos, and so on and so forth. Okay, I hope this is fun, because whether it's fun or not, you have to learn it, because this is affecting your future, the environment and the climate for your future. You are the future is yours, so you should be at least aware of what the old people like me are doing and what you may be forced to do because you don't know what you're doing, and what you can do once you become aware of all the bad things that happen when we keep on doing the things we are doing, consuming a lot of energy, wasting a lot of energy, eating a lot of meat, and wasting a lot of food and water and so on and so forth. Okay, see you in the next chapter to talk about stormy weather. So climate change also makes more stormy weather, as we will see. Okay, see you in the next podcast.